So the next chapter that we are starting is chapter number 4. It's on page 143. And this chapter is about probability and odds. Have you ever heard this thing before, these two terms? What's probability and what are the odds in favor or odds that are not in favor? Have you ever heard these terms? No? Great, no? Okay, so let's talk about the definitions first. I will just talk about the first topic today. It's about probability. Maybe it will take about 2 or 3 classes to finish this first topic, probability, and then maybe on Thursday and Friday we will talk about the odds. So let's just concentrate on probability first of all. So what do we mean by probability is the chances of something to happen. For example, you can say there are 20% chances that it will rain today. You can go to a weather website, they will say that there are 10% chances of shower, right? That's the probability. There are 20% chances that this thing will happen today. There will be rain today, 20%. So you will say, how much is the probability that it will rain today? You say 20% probability, right? Okay, what is the probability that it will not rain today? This is that it will rain today. You know that 20% chances that it will rain today. That's what you get from the weather website. But if I ask you, what's the probability that it will not rain today? How much is the probability that it will not rain today? 80%, yes. Because everything is 100%, right? So if there are chances that it will rain today, the chances are 20%. 80% chances means it will not rain today. So the probability of not raining is 80%. The probability of raining is 20%. Another example. Let's say you toss a coin. How many chances are there that it will land head at the top? 50, because there are only 2 sides. It can land heads or it can land tails, because there are only 2 sides of the coin. There are equal chances that when it comes down to the ground, it will have heads up or tails up, because there are only 2 different sides. Right? So tossing a coin, the chances that it lands heads is 50%. The chances that it lands tails is also 50%. Right? So what is the probability that it lands heads is 50%. Same thing for the tails. The third example, let's say that you roll a die. Well, some people call it dice, some die. So you roll a dice. You know that there are 6 different faces of that dice, and they are dotted with 1 dot, 2 dots, 3 dots, 4 dots, 5 and 6 dots, right? My question is that how many chances are there that when you roll a dice, you have a 1 dot at the top? How many chances are there? 1 out of 6, because there are 6 different faces and each face has equal chances, right? That means how many chances that you will have 1 dot at the top, 1 dot at the top. The chances are 1 out of 6.
Do you divide 1 by 6?
Yes, you can also write it as 1 divided by 6. And how many chances are there that it will have 2 dots at the top when you roll a dice?
2 out of 6.
Why 2 out of 6? This is the dice. Let us say this one has 1 dot, this one has 2 dots, this one has 3 dots.
It's still 1 out of 6.
It's still 1 out of 6 because every face has equal chances.
Yeah.
It doesn't matter if it's 1 dot or 2 dots, right? Because every face has equal chances. That you can say that there is only 1 out of 6 chances of this, 1 out of 6 chances of this, 1 out of 6 chances of this. Every face has equal chances. It does not depend on the number of dots, right? Every face has equal chances. So the chances that you will have 1 dot at the top is 1 out of 6. And if my question changes to this, that what are the chances that there will be 2 dots at the top, it is still 1 out of 6 because every face has equal chances. This is all about probability. You tell that how many chances are there that that event will happen or that event will not happen. So if there are chances, 1 out of 6 chances that there will be 1 dot at the top, like this one, how many chances are there that there will be no 1 dot at the top?
0.
Why?
They all have dots. What do you mean no dots?
Okay, no, the one dot is not at the top. Anything else can be at the top. It can be 2 dots, it can be 3 dots, it can be 4 dots, 5 dots, or 6 dots.
5 out of 6.
5 out of 6 because there are 5 other types of faces, right? The chances that 1 dot will not be at the top, how many chances are there? 5 out of 6. 5 out of 6 of 1 dot not at the top. Because it can be 2 dots at the top, it can be 3 dots at the top, 4, 5 or 6 dots at the top. There are 5 other faces that are not this face. The chances of landing any other face except this one will be 5 out of 6. Right? So this is all about probability. There are different ways to report probability. You first need to understand that how do we write probability. You can write the probability as a percent like this. When we say that the probability is 20%, this is one way of reporting the probability. The same probability can also be written as a decimal. You know that 20% is same as writing 0.20. So 20% probability is same as 0.20 probability. You just convert this percent into a decimal, right? There is another way of writing the probability. This was as a percent. This is as a decimal. And you can also write a fraction to display probability. How will you write this number as a fraction? How do you convert a decimal into a fraction? Yeah. Yes, because 20, when you write 0.20, you put a dividing line underneath, and then where you see this dot, you put a 1, and then count how many decimal places are there. There are 2 decimal places, you put 2 zeros, and then you remove this decimal. So 0.20 is same as 20 divided by 100. But then you need to simplify it. You know that you can write this in the minimum form. If you divide this by 20, you get a 1. And if you divide this by 20, you get a 5. So it's 1 out of 5. 20 out of 100 is same as 1 out of 5. You just simplify this fraction to the minimum terms. And the fourth way to write this is writing this thing. You can say this is 1 out of 5. This is a ratio. So the probability can be written in these 4 different ways. You can write a probability as a percent, or you change this into a decimal, or you change this into a fraction, and then you write it as 1 out of 5. You can say 20 out of 100. It is same as 1 out of 5, right? So whenever you answer a probability question, you will have to write all of them, unless it is asked like specifically to be written in percent or something. If they don't ask anything specific, you should write all of them. It is just a conversion from one type to another. You can find your answer in any of these forms, and then you will convert it into the other forms. For example, if I give you that it's 0.20, you know that if you multiply the decimal 0.20, if you multiply it by 100, it will change into a percent, right? And if you divide this percent by 100, it changes into a decimal. Converting decimal to percent means you multiply it by 100, and converting percent into a decimal means you divide this number by 100. And then this is just simplification of the fraction. And this is just writing this thing in other words. Instead of writing like a division, you just write it as 1 out of 5. It's a simple process. You will learn this with practice. Okay, let's try to solve some problems based on probability. I want you to open your books on page number 146. And on this page you see there are two definitions given on the lower left corner of this page. The first definition is how you define this term, probability. You can also call this as theoretical probability. And the other term you need to define is the experimental probability. So what's the probability or theoretical probability, and what's the experimental probability? You need to understand the difference between these two terms. The first one, the theoretical probability, it says the chance of an event happening expressed as a percent, fraction, decimal, or in words. The chances of an event happening. The chances of an event happening. This is the theoretical probability. For example, let's say you toss a coin, and what are the chances of landing heads and tails? Equal chances, 50% each, right? Tossing a coin, the chances are 50-50. The chances of heads and tails are 50% each. You can write it as 50%, or you can write it as 0.5 and 0.5. 0.5 is same as 50%. Or you can write it as 50 divided by 100, which is 1 over 2. This is also 1 over 2. Or you can write it as 1 out of 2. 1 out of 2. There are 4 different ways to answer this question. As a percent, as a decimal, as a fraction, or in words. They're all the same things. So tossing a coin, there are 50-50 chances that it will land heads or tails. Have you done this tossing? No, you think about it and you know that there are equal chances that it will land either heads or tails. You haven't done this experiment yet. It's just about the thoughts. It's theoretical. It's theoretical probability, right? But when you actually perform the experiment and see what happens, that probability will be called what? That will be experimental probability. Let's say you now actually perform this event and you do it multiple times, right? Let's say I toss a coin and it lands. Let's make two columns, this for the heads, this for the tails. Let's say I perform this experiment 100 times, right? And let us say 60 times it lands heads and 40 times it lands tails. Out of 100, 60 times it lands heads and 40 times it lands tails. So what's the probability, the experimental probability of having heads? 60%, right? Because it was out of 100. We had 100 different experiments done and we got 60 out of 100, which is 60%, right? So the probability, the experimental probability of having heads is 60% and having the tails is only 40%. Is this probability same as the theoretical probability? No, it's not. Well, ideally, this is the ideal condition. You will see, you want to have the equal probability, but when you do the experiment and you do it only 100 times, you will have these things not exactly 50-50. They can be 65-45. They can be 40 on this side or 60 on that side. It won't be exactly same. It's not an ideal condition. It's just, this is the experimental thing. You have done this actually. It might not be same as the theoretical probability. But when you repeat this, let us say you just keep repeating this procedure and you do it 20,000 times. You do the same tossing 20,000 times. It's a very, very large sample space. We say that this is the sample space. Sample space means how many times you have repeated that experiment. When you have a very large sample space, you repeat that experiment multiple times, like 20,000 times, then you will have this thing 10,000 in this column and 10,000 in that column. Now this probability will be equal. So you will achieve this thing, ideal thing, when your sample space is large, right? When the number of experiments in experimental probability is very large, then this probability will become equal to the theoretical ideal probability. But if you just want to do this experiment twice, let's say you toss the coin first time and you get a heads, and the next time you toss a coin, it's not mandatory to have a tails. You might end up having the same thing next time. So how many times you got the heads? 2 different times. How many times you got tails? 0 times. So if you want to write this probability in percent, what will be the percentage? This is 200% now, and this is 0%. Or you can say just 100% this one, and that's 0%, which is not ideal, which is not theoretical. But when you repeat your experiment multiple times, the larger is the sample space, the closer will be these results to the theoretical probability. So what's the difference between theoretical and experimental? Theoretical means that is the ideal thing, that's the chances of an event happening. You don't do that experiment, you just think about the experiment and you suppose that this will happen. The experimental probability, when you actually do the experiment, report your results and then calculate the probability, right? So that's the main difference between the theoretical and experimental probability. The first chapter that we are doing is all about the first type of probability. Let me see if it is first type or second type. No, that's about the experimental probability. The next one will be about theoretical probability. Let's try to solve some examples and then you will have this idea better explained. Okay, look at the first example. Example number 3 on page 147. And read the question. It says Georgina bought a bag of bulk candies. She counted them and found that 15 were red. Let's say this is the bag of the candies. You have candies placed in this bag. And out of everything that's in this bag, there are 15 red candies, 10 green candies, 12 purple candies, and then you have another type, the fourth type, 13 orange candies. How many candies are there in total? You'll add them up. Total candies, 15 plus 10 plus 12 plus 13. What's the total? 50, yes. Now the first question is, read the first question. Question A. Read this question please from your book. What is question A? Calculate the probability of a randomly chosen candy from the bag being red. Then express the probability as a fraction, a decimal, a percent, and in words. Choose a random candy and you have to find the chances of that candy being red. You randomly select a candy. You don't look at these candies. It's all in one box and you can't see what's in there. You put your hand into the box and then you pick up a candy. You don't know what color will that be. You have to calculate that what is the probability or how many chances are there that the candy that you choose is the red candy. How many chances will be there? Do you understand the question? Okay, you have 15 red candies and you have total of 50 candies. Let's try to make this problem simple. Let's say you have 5 cards or 4 cards placed in a box. This card has 1 dot, this card has 2 dots, this has 3 dots, this has 4 dots. You don't look at them, you just put your hand into this box and pick up one card, right? And I ask you, how many chances are there that the card that you picked up has 1 dot on it? How many? 1 out of 4. 1 out of 4, because there is only one card that has 1 dot on it. There is only 1 out of 4 chances. 4 means because there are 4 cards in total. So picking up the card with 1 dot, how many chances are there? 1 out of 4. Because there is only 1 card with 1 dot. That's this one, and there are a total of 4 cards. Similarly, how many chances are there that the randomly chosen candy is red? How many red candies are there? 15. And how many total candies are there? 50. That is 15 out of 50. Just like this, 1 out of 4. So how many chances are there that the randomly chosen candy will be red? That is 15 out of 50. Because there are 15 red candies, that's this 15, and there are 50 candies in total. 15 out of 50. So that's the probability of choosing a red candy when you randomly select a candy. But that's writing this thing in words. You have to write it in different forms. You will write it as 15 divided by 50.
0.3?
Yes. 0 point?
Yeah, 0.3.
0.3 exactly?
That's all it says, yeah.
Okay, so that's the probability written in decimal. How will you write this in percent? I told you to change decimal into percent, you multiply the decimal by 100.
30%.
Yeah, that will be 30%. And then you can write it as a fraction. This is already a fraction, 15 over 50. But you have to simplify it. You have to write this in the minimum terms. You know that both these numbers can be divided by 5 because 5 is a common factor for both of them. Dividing 15 by 5 will give you 3, and dividing 50 by 5 gives you a 10. So this is the fraction, 3 out of 10, and writing this in words will be 3 out of 10. You shouldn't write it like this. This was just to help you out to understand the question. You should always write in the minimum form, 3 out of 10, although it is same as this, but you should use these numbers when you write the fraction in the minimum terms. Only then change it into words. Don't write this one. This is only to help you understand the question. So these are your 4 answers. The first answer is the decimal, then the percent, then fraction, and then in words. So that is the probability of choosing a red candy out of these 50 candies. There are 3 out of 10 chances that the randomly selected candy will be red. If you attempt 10 different chances, you will get 3 candies that are red. But that is theoretical probability. It's not an idealized condition. When you actually perform the experiment, it can vary. It can be 2 or 4. Because this is the theoretical probability. That's what we think will be ideal. Right? Okay, the next question, B. Read the question. What is the probability of a randomly chosen candy being green or purple? So you have to find a randomly chosen candy that is green or purple. Green or purple. It's not green and purple separately. It can be either of them. It can be either green or purple. So you randomly select a candy and you have to find that how many chances are there that the selected candy will be either green or purple. How many green candies are there?
10.
What are the chances of choosing a green candy? 10 out of 50. What are the chances of choosing a purple candy? 12 out of 50. What are the chances of choosing one of them? It can be either green or purple. You add them up, 10 and 12, which is 22. 22 out of 50 chances are there that the selected candy will be either green or purple. It's green or purple. It can be any of them. Whether it's green or purple, that's all okay. So we will have to add them up, 10 and 12. So how many chances are there? What's the probability? You should write it as 10 plus 12, first of all, divided by the total number of candies, which is 50. So this is equal to 22 over 50. So you first need to simplify it. What's the common factor between 22 and 50? What's the number that I can use to divide both of them?
Yeah, 44%.
Sorry? No, but I just want to write this in the minimum form first.
Oh,
The fraction. I want a common factor that will divide both of them. 2. Yes, you can divide both of them by 2. When you divide 22 by 2, you get 11. And then you divide 50 by 2, you get 25. There is no other common factor because 11 is a prime number, right? So this is the fraction, the probability written in fraction. And then you can use your calculator to find what is 11 divided by 25. How much is that? 11 divided by 25. Sorry?
0.44.
0.44. And how many percent will that be?
44%.
44%, because you can multiply this by 100 and that will give you the percent. And how will you write this in words? 11 out of 25. These are 4 different ways to write your answer. This is the fraction, decimal, percent, and in words. Now read the next question, part C. And in that question, it is asking if the distribution of colors in a bag of 1000 candies is the same, how many would Georgina expect to be red? What's the current number, all the candies altogether? 50, right? You want to increase the number, you want to make a total of 1000 candies. So you want 1000 candies in this bag, but you don't want to change the ratio. The ratio should still be the same. That means they should be increased by the same proportion, right? So if you want to add another 50 more candies into this bag, make sure that those 50 candies got the same proportion of each color. You just keep repeating this until you get 1000 candies. What do you think? How many red candies will there be when you have 1000 candies in total in the bag? For every 50 candies added, you will be adding 15 red candies. You just keep increasing this number until you get a total of 1000 candies. How many red candies will be there when you have, sorry? How many? 300?
1,000 divided by 13.
Well, you can first find the percentage of 15 candies. It's 15 out of 50. That's what we have right now for the red candies. Yeah, right? 15 red candies out of 50, that's what we have right now. And if you change this into percent, what was the number that you got? Was it 30%? When you divide 15 by 50?
Yeah.
Was that 30%? Okay, so 30% candies are red right now. When you have 1000 candies, that percentage should still be the same. So when you have 1000 candies, what's the 30% of 1000? That's 0.30 times 1000 is equal to 300 candies. So when you have a total of 1000 candies, the red candies will be 300. How I have done this? I found the percentage of red candies what we have right now. 15 red candies out of 50, that's 30%. When you increase this number to 1000, the red candies percentage will still be 30%. So you want to find what is 30% of 1000 because that's your new number. And off is changed into multiply, percent is changed into decimal. 0.30 times 1000 is equal to 300. So when you have this bag full of 1000 candies, out of 1000, 300 will be red. Similarly, you can find the proportion for the other candies also. Right? You first find the percent. For example, if you want to find how many purple candies will be there, you will first find the percentage of purple right now. That will be 12 divided by 50. That's the percentage right now. How much is this? 12 divided by 50. Sorry?
24.
Exact?
Yep.
24%. And when you have 1000 candies in total, so you will find 20% of 1000. That's 0.24 times 1000, which is equal to 240 candies. So 240 candies will be purple when you have 1000 candies with the same proportion. So you're basically finding the percent from this number and then you use that percentage in the new case. Right? Okay, this was an introduction to the probability. Let's look at build your skills problems. These are pretty simple problems and they will help you understand the probability in more detail. Look at the first question, 3A on page 148. Okay, this one is 148 and question number 3A, A and B. Okay, read the question. It says a grocery store sells 3 brands of toothpaste. Last month the store sold 75 tubes of brand A. So brand A they sold 75 tubes. This was the last month figures. And they sold 75 tubes of brand A, 23 tubes of brand B. Brand B, they sold 23 tubes. And then 57 tubes of brand C. 57 tubes of brand C. The question is, what is the probability of a customer buying a tube of brand A? How many chances are there that a randomly selected customer bought brand A? You just think about a customer going into their store and buying the tubes. What are the chances that he will buy brand A based on this data? You can see that brand A sells the most, right?
You add them all up and then 75 over the total.
Yes, yeah. You see that these are 75 tubes sold, which is the largest number. So there are more chances that a randomly selected customer will select this tube, brand A, because it sells more. It's more popular, right? But how will you find the exact probability that that customer will purchase this tube? You first need to add them up. You know how you find the probability? You can actually note down this formula. How do we find the probability? The probability is number of chances of event, the event that you're talking about, divided by the total number. Total number. That's the formula always. So you will have to calculate the number of chances of the event that you are talking about. Our event is brand A. Its number is 75. The total number is the sum of all of them. You should note this formula down because this is used all the time. What's the probability? Number of chances of event that you're talking about divided by the total number of chances. Okay, so for our case, the total number of chances, you first need to add them up. 5 plus 3 is 8, plus 7, 15. 8 and 2, 10, and 5, 15. So there are 155 total number of chances. So what's the probability of brand A? Okay, this is something that you need to learn. How do we write the probability that he will choose brand A? Use P for probability, and then in the bracket write the event name. The event name is brand A. So you will write this, probability of choosing brand A. That's how we read it. Probability of choosing brand A, or probability of selecting brand A. We write P for probability, and in the bracket we write the name of the event that we are talking about, the one that we are finding the probability for. That's the event name, brand A. How do we find its probability? At the top goes the number of chances of this event, which is 75, divided by the total number of chances, which is 155. So now you divide them, but you first need to simplify this so that you can write it as a simplified fraction. So what's the common factor between 75 and 155? 5. Divide both of them by 5. What's 75 divided by 5? 15. And what's 155 divided by 5?
31.
31. Is there any other common factor between 15 and 31? Or will you stop here? Do you see any other common factor that you can use to divide them? No. Because 31 is a prime number, right? So this is the probability written in fraction. Okay, what's the decimal equivalent of this? When you divide 75 by 155, what's the decimal equivalent?
0.48.
0.38.
48.
Sorry, 48.
But there's other stuff after it. So
What comes after 8?
483.
Yeah, then you can leave it as 8. That's fine. Yeah.
Okay.
Yeah. The question only asks you to answer in a simplified fraction, so you don't even need to do this. That's your final answer. That's the question is asking you to write your answer just in simplified fraction. So you don't have to convert this into decimal or percent. You can stop here. So that is the probability that a randomly selected customer will select brand A tube. There are 15 out of 31 chances that the customer will pick brand A. Right? Now read the next question B. Part B. If the store sells 500 tubes of toothpaste the next month, how many tubes of brand B can they expect to sell? Brand B. What's the percentage of brand B right now this month? 23 divided by 155, right? Brand B. How will you write its probability? You write it as probability of brand B is equal to the number of tubes sold, 23, divided by the total number of tubes sold, 155. 23 divided by 155. What's the number in decimal?
0.148.
0.148. Okay, now if you increase the number of tubes from 155 to 500, the next month if they sell a total of 500 tubes instead of 155, how many of those will be brand B? That will be 0.148 times 500. You multiply them, what do you get? 0.148 times 500.
74.
74. That means if they sell 500 tubes, out of those 500, 74 will be brand B tubes. Right? So you just use the probability from the previous month to find the number for the next month. Okay, the next one, question number 4. This is on next page 149. Question 4. There's a table given, and I will draw that table for you. It has the blood type in the first column, in the first row, and the second row is about the number of donors. First blood type is O positive, and there are 327 donors with this blood type. 277 donors of type A plus, 77 of B plus, 27 of AB plus, and then 69 with O negative, '56 with A negative, '16 with B negative, and then you have another type, AB negative. How many? Just one. This is a very rare group, AB negative. People with this blood group, they are kind of unlucky people. If they need it, it's hard to get. Anyway, so these are the numbers given, and the first question, A, you have to find the probability that a person selected at random has the following blood type. B positive. So if you randomly select a person that, let's say there are lots of people sitting in a room, and out of them 327 are O positive, 277 are A plus, and so on. You randomly pick up a person out of them. What are the chances that the randomly selected person will have this blood group, B positive?
You add them all up.
Yes, you have to find the total. That's how we find the probability. You have to find the probability that the person has this blood group. So it's P of B positive. That's how you write it. Make it a practice. You have to learn how to write this. P means you're finding the probability. Whose probability you're finding? The person with this blood group, B positive. And how do you find the probability? The number of people with this blood group, which is 77, divided by the total number. You'll have to add them up. So what's the total?
850.
850. Is that right? Yes. So 77 is the number of people with B positive blood group divided by the total number, which is 850. And we have to express our answer as what? It doesn't say anything. So you have to write all the types: percent, decimal, simplified fraction, and words. First of all, can you simplify it further? Is there a common factor that you can use to divide both of them?
No.
Yes? Well, you can try 7. Can you divide this by 7? 850, can you divide it by 7? Because 77 can be divided by 7. Can you divide 850 by 7?
It's a decimal.
No. Can you divide this by 11? Because 77 can be divided by 11 also. Can you divide 850 by 11?
How about 2? No.
2, you can't divide 77 by 2.
No.
Right? You can't.
Give it a shot. 3.
Can you divide this by 3? Try it. 77 divided by 3. If you get a decimal number, then you can't. No. So there is nothing that you can do about it. That's already simplified.
Okay.
Right? So that's the answer in simplified fraction. Now you have to write it as a decimal. So you divide 77 by 850.
0.09. So it's 9%.
0.09, okay, it's 0.09, and to change this decimal into percent, you multiply this by 100. This is equal to 9%. And then you write it in words also. How will you write this in words? 77
out of 850.
out of 850. So that is the probability that a randomly selected person will have a blood group of B positive. There are only 9% chances that the randomly selected person will have this blood group. Can you find the probability that the randomly selected person will have a blood group of AB negative? 1 divided by 850. What percent will that be?
It's always 850.
1 divided by 8, it's 1 in 850.
Yeah.
It's so small. What percentage is that? 1 divided by 850 times 100.
0.001.
Did you multiply it by 100 already? Because you have to convert decimal into percent by multiplying it with 100. 0 point?
11.
Yeah, it's so small. It's less than 1% chances, just 0.1% chances that the person will be of this blood group. Right? It's very rare. And what about O? If it's O, you want to find the probability that he will have a blood group of O. This is a tricky question. What are the chances, what's the probability that this randomly selected person will have O blood group? Do you see blood group O in this?
69. Then the O minus is
327.
This is O positive. I'm just talking about O. There is O positive and O negative. There is no O.
Okay.
O means you will have to include both of them because they're both O. Their RH factor is different, it's positive and negative, but the blood group is O. So what's the probability of finding this blood group? You will have to add them up. 327 plus 69. 327 plus 69 divided by 850. Because they are both group O. Right? How much is this? 327
0.4.
plus 69. What's the total first of all at the top? What's their sum? Did you get this, Stephanie?
396.
396 divided by 850. Okay, let's simplify it first of all. What's the common factor between them?
2.
2, yes, you can divide them by 2. So what do you get when you divide both of them by 2? What is 396 divided by 2?
198.
198. And this will be
425.
425.
425. Is there any more common factors? If 2 is definitely not there because this is
5.
this is an odd number. So you can try 3. You can divide this by 3. Just try 3. Divide 198 by 3. You get a whole number, right? But can you divide this by 3?
No.
425? No, you get a decimal number. 4, 5, 6, 7. Well, you won't have any other common factor. You can try all of them, but there is none. So you will write this as 198 out of 425. This is 198 out of 425. And to write this in decimal, you divide them. 198 divided by 425. What number do you get?
0.46.
0.46. And this is equal to 46%. Is that 0.46? What is after 6?
5.
Yeah, then you have to change it into 7 because it's 5. It will be 47%. When the next number is 5 or more, you have to increase this by 1 when you round it off. Even if it is 5, the previous number will be increased by 1. So it's 47%, or you can write it as 198 out of 425. Okay, the next question, part B of this. The question asks you to approximate, if the data approximately represent the blood type distribution of the general population, how many people in a group of 5,000 are likely to have AB positive blood? It's the similar question that we did last time for those candies, when you increased their number from 50 to 1,000. Now they're increasing the number, the total number from 850 to 5,000. Their sample space is much larger now. They have got more people. But their percentage is not going to change, right? So you have to find out that how many people will be there with the blood group of AB positive, this blood group, if the number is increased from a total of 850 to 5,000. First of all, you find the probability in decimal of AB positive, what we have right now. So find the probability of AB positive group. Probability of AB positive group, it's 27 out of 850. 27 out of 850. Change this into a decimal number, divide them by a calculator or whatever. What do you get for this division? 27 out of 850.
0.017.
0.317.
0317.
Let's change it to 2 then, if it's 17. And because this is not going to change even if the number is increased, so how many people will be there in 5,000? You will multiply 0.032 times 5,000. So what's their multiplication? So this will be number of people
160.
with AB positive blood group. How many?
160.
160. This much?
Yeah.
Okay. So there will be 160 people with the AB positive blood group if the number is increased from 850 to 5,000. So out of 5,000, 160 will be with this blood group, AB positive. The probability doesn't change, it stays 0.032. Even if you divide 160 by 5,000, you will still get 0.032. I want you to try the next question, number 5, on your own. 5A and B. Just try it.